So I'm here with Kevin Sherwin. He won first place at LICEP in the math category, which he proceeded to go to ICEP, and he won fourth place over there under math as well, right?
Yes.
Great. So tell me a bit about your project. Like, what's the title? What is it?
So the title is Classifying Generic Smooth Curves in the Projected Plane Related to Algebraic Curves of Degree 5.
Wow.
And in essence, what I did is I showed that this old system of classifying curves, called the Arnold invariant system, which was highly effective in classifying curves of up to degree 4, was highly ineffective in classifying curves of degree 5. And this really points to a whole new classification system.
So what was like the underlying purpose of your entire study?
Well, initially my purpose was to simply classify and construct the class of degree 5 curves, because this had never been done. And I found that while doing this, I found a really great finding that this old system that people thought was highly effective is really quite flawed. Oh,
wow. All right. So I know that you worked on this over the summer at Stony Brook.
Yes.
And you kind of had an unusual way of going about.
Yes.
So can you care to tell me a bit about your research experience? What did you do day to day?
Well, at first I reached out to a professor in the spring of my junior year, and we worked it out so that I met with him about 3 times a week over the summer for about 2 hours, 1 to 2 hours each, and I would travel up to Stony Brook, and the majority of my work was done at home after learning about the topic and getting some certain assignments.
Okay, so what exactly was like the data collection?
Well, my project was really unique, and it was in topology, and a great deal of topology is drawing, and you have to draw these curves and sort of draw these knots, because it's knot theory. Yeah.
All right, so can you just tell me like a basic overview of the method that you employed in general as possible?
So I did a project that was supposed to classify curves, just like, the curve x squared plus y squared equals 9, which is a circle. And I did a project in topology, which basically tries to classify these curves in ways not using those equations that I mentioned. And so in this case, I used the system called the Arnold invariance, which is a set of 3 numerical values that would go to classify a curve that could be, represented by some random equation. And I basically found that for curves of degree 5, which have at most 5 solutions, x squared plus y squared equals 9 is a 2nd degree equation. So, x to the 5th plus y to the 5th will be a 5th degree equation. I found that this old set of classification, the Arnold invariants, are ineffective in classifying all of these curves, which are of degree 5.
So what were you able to conclude / find?
Well, I concluded that the Arnold invariants, which we were talking about before, these numerical values for the curves, are highly ineffective in classifying curves of degree 5. Now, why is this significant? Well, they were very effective in classifying curves of up to degree 4. So this is kind of a breakthrough in this subfield.
Cool. And where can you apply what you found?
Well, it's a good question. My project was in theoretical mathematics for start, so this is the project I did, and I didn't really look directly to the applications. But invariance in general, and this will definitely have practical applications if followed through with by an applied mathematician. In the fields of quantum computing, which is a huge breakthrough field right now, electric circuits, graph theory, which has applications in business, science, you name it, and computer circuitry.
How do you describe the research experience for the past 4 years? Your experience, I know, is kind of unique because you used to be in math and then you came here. So
my research experience was definitely a great experience. It was definitely an experience, and I think that's the greatest part about the research program. You gain a lot of experience dealing with, getting assignments in and presenting and doing your own research, which is tremendously satisfying, and also the experience of reaching out to a professor and being a professional, like as if you were a graduate student, but 16, 17.
Right. And what would you say your most memorable experience?
My most memorable experience.
Mm-hmm.
I don't know, it was really satisfying presenting at ISEF for the
Yeah.
judges and gaining such a positive reception,
Mm-hmm.
and it was really fun.